Excellent. So, you have any big wins for this week?
Um, yeah, well, I guess was able to make some headway um, about the project I'm working on, and be able to divide and conquer and come up, break the, you know, break the requirements into different tasks and got got folks assigned to work on them. I think it's going well. Um, Personal level, I think in my personal life, I was able to contact some cancer center and
Mhm.
was able to get some clarity um, about the next steps. So we're not going
Excellent.
to Houston at this moment, not
Okay.
MD Anderson. Yeah, most likely we'll find something local like Johns Hopkins for my
Okay.
dad's treatment. So
Excellent.
that's also going well. Yeah.
Very good. I'm glad to hear it. Yeah, that's I can understand the frustration and all that. That's
Mhm.
it's scary and it's so out of your control. So
Yeah.
yeah,
I had
you
to
do what you
learn a
got.
lot of the medical terminology.
Right.
Yeah.
Yeah. You feel like you have to become a doctor all of a sudden. Well, that's where AI can come in handy. I tell you what. I
Mhm.
was reading an article yesterday that a lot of people are, you know, they're having the ChatGPT go and diagnose their illness and rashes and that sort of thing, and
Mhm.
second guessing their doctors by asking ChatGPT and that sort of thing. So it's like, yeah, very exciting. We are in living in interesting times.
Yeah, for sure.
Okay, so um, it looks like nobody else can make it today, so you got me all to yourself. I am going to. What was last week's session helpful for you? Did that?
Yeah. It was a very important topic. But how do we internalize the principle? I feel like that's the tough part. Like it had to do with discipline, with habit and a lot of things. So
Well,
mm,
um, so and now I'm drawing a blank. Okay, so the way you incorporate it is it's like I said, it's a mindset that you have to be think. Just picture yourself as not an employee, but as an independent consultant. Does that make sense? Uh,
yeah.
I'm sure you've got some consultants who are working with you on some
Yeah.
capacity, and
Mhm.
you see that they carry themselves differently. More than likely, they probably dress differently. They probably dress a little bit nicer than most of the other people who are employees.
Mhm.
Um, so they just hold themselves to a slightly higher professional standard than the people around them, and and that would be the simplest, the I guess the most obvious first step to do is just make sure that you are taking
Different.
ownership of the work that you're doing
Okay. Yeah.
and saying, okay, this reflects on me and my reputation. And so I need to make sure that my reputation is exemplary. there's a there's a guy that I work with. He just retired, but he always wore a necktie. Every day he wore a necktie, button-down shirt with a necktie. And I asked him, so why is it? Because most most of the people he worked with, they'd be wearing shorts and flip flops and t-shirts, and he was always dressed very professionally. And even the employees, everybody, and I said, so why is it you're always wearing a tie? He said, you will not believe the opportunities that wearing this necktie has afforded me in my career. When senior management needed to show off some new tool or technology or something, even if I wasn't necessarily involved with it, they would invite me into the meeting because they knew that I would always look and act professional and I would make a good impression on the customer. So I have been put into customer facing situations and management facing situations just because I dressed a little bit more professionally. I thought, holy cow, I wish I'd heard that at the beginning of my career rather than the end. that
Yeah.
that makes a lot of sense. And and it's a small thing. I mean, nobody likes to wear a tie. It's not necessarily comfortable, but if you're wanting to be noticed by senior management, it's a small thing that stands out, and it separates you from the rest, and it's not real hard to do.
Mhm.
So
Okay.
I don't know if it would make sense for you to do it in your current capacity, but give it a try. What have you got to lose, right?
Still makes sense. But I work from home. But I
Oh,
guess
okay,
the customer is my wife.
right. But if you ever have to go into the office, do they ever call you into the office once or twice a year for staff
Yeah,
meetings or anything like
yeah,
that?
once a month.
Okay. Well, then you be the one who dresses up.
Yeah, I I underdressed like
Yeah.
last time. I was I, I didn't mean to work from office. I just went there to pick up something.
Yeah.
Then everybody was in office, and
Yeah.
I was with on a flip flop and a beach shirt and then
Oh
shorts.
man. Oops.
Yeah, yeah,
Yeah. Well, so now you know, even if you're going into the office to just pick something up, just in case, it's best to
yeah,
dress a little
definitely.
nicer in case someone sees you.
Yeah.
Okay. Very good. Um, and and the other things, you going to the conferences that you do and going through this program, that's going to help you to expand your knowledge and your self-image so that you carry yourself more professionally. You speak more professionally. You're able to have conversations on a deeper level with people. So I think that should come.
Yeah, good point.
Okay. So yeah, just and thinking about you know just like I said, think about yourself as a consultant, and you're no longer an employee who's working for the company. You could be let go at any time, and that's true whether or not you're an employee. But if you're operating from that position, you will you'll be ready for a change when it comes, and they'll see you as the one who seems to have the answers and has just a different attitude than the rest. And every manager, every manager knows if I've got to cut somebody, they know who the first person they're going to cut is.
Mhm.
And if I've got to cut three people, I know who those people are. And he's just always got a hierarchy in his head. So, your job is to make your manager think that you're the one who's going to make him successful.
Mhm.
And if he has to cut, then you would be far too important to cut.
Mhm.
Does that make sense?
Yeah. Mhm.
Okay. So this week I want to. This is kind of a big topic. Um, so I'll cover the first half of it this week and the next half of it next week. Um, but I want to introduce you to the idea of uh, reading code that you're not familiar with. So let me go and share my screen. There we go. Right there. All right. Um, can you excuse me for just a second? I need to close the door.
Mhm.
Neighbors doing the lawn and it's getting noisy. So, all right. So basically, the first thing we need to cover here is reading code. If you're like most developers, you spend more of your day reading code than you do writing it. So let's dig into that. All right. One thing I like to tell people is that this is my favorite quote from Kent Beck, and this is kind of what I use as my guiding principle. I'm not really a great programmer. I'm a good programmer, but I have great habits. So I want to make sure I develop the habits that I need in order to at least be perceived as a great programmer. Um, so there's a speaker I heard say once that our lives change when our habits change. So my goal here is to help you learn some new habits that are going to have a positive impact on your career. So if you think about it, in Steve McConnell wrote this book. When was that? Back in 2004, um, called Code Complete, and he said if there was a scientific study that they did. This was a study from back in 1964, where they measured how programmers spent their time in any given work week, and they spend 14% of their time reading source code and 13% of their time writing source code, and the rest of that time would be like in meetings or researching stuff or whatever. And he said that in the since then he hasn't seen anything that he would consider as would change those numbers much. Um, so in the late whatever around 2009 something like that, clean Robert Dr. Bob Uncle Bob Rob Martin wrote the book Clean Code, and he claims that developers spend 90% of their time reading code. He didn't reference any studies, but I'll let him and Steve duke it all out. um, and then I was reading few years ago that there was a study from the IEEE that said that they find that on average, developers spend about 58% of their time on program comprehension activities. So that is reading and trying to understand code. So whether it's 50% or 90%, whatever, at least half your time is spent reading code. And there are dozens of essential books that I could recommend on writing great code. Can you think of even one that suggests how to read code? Um, I
Yeah, the
will.
programmer's brain,
Right, right,
maybe.
right. Yeah. So, and that is probably the best one that I've read. in that respect, and I'll be referencing that a lot in here. Have you read that book?
Um, I I read the preview long back, and then after our initial call, we we talked about that, right? And then
Right.
I purchased the audiobook, so I've been listening to that.
Okay, very good. Well, then a lot of this should sound familiar. Then I'll just try and uh, help it make more sense to you. All right. So, so what are some of the problems you run into when you're trying to read code? What are some of the struggles that you run into?
Yeah, so without knowing the design pattern and the best practice, um, and so that's one
Right.
hurdle, and the other one that I can think of is the code base is too complex,
Mm-hmm.
um, so don't know where to start.
Right.
And
Right. So yeah. So all of these and so I want to make sure I explain all this to you and how we can approach it. So, reading code isn't the same as reading a good book. You can sit down in a comfy, easy chair with a glass of wine and enjoy a good book. But all you really need to do is more or less remember the characters and their relationships and what they do. But unless you're reading a mystery novel or a technical document, um, you don't really have to pay particularly close attention to the details. If you're reading code, you probably have to have a pen and paper, and you need to take notes. You probably need to scribble, on printouts and that sort of thing. You need to follow the flow of what it is you're reading, and frankly, it's hard work to read code. And when you're writing code, that's another thing. Both prose and code take a lot of planning and rework. Um, this this is Ernest Hemingway. I don't know if you've heard of him. Wrote The Old Man and the Sea, The Sun Also Rises, that sort of thing. Um, he would revise the books that he was working on many times before he released the ultimate masterpieces that he had. And I'll tell the people that I work with a lot of times, don't think that your first working solution is ready for production. You're not better than Hemingway. Go back and refactor your code, make it better. Um, so, what makes code hard to read? And here's some of the ideas I came up with for what makes code hard to read. Someone else wrote it. I wrote it, but I must have been drunk when I wrote it. There's no documentation. Even if there is documentation, it's probably not kept up to date. People aren't following our coding standards, so things don't line up the way they should. They're using magic numbers. I don't know what these numbers. What does 315 mean? I don't know. They're reusing variables, like they'll have a class variable and then they'll reuse the same variable in a function, and you don't know which version they're using. They'll have these huge class files that run on for 5,000 lines. And how do you keep track of it all? Um, Global variables or singletons can have surprising side effects. Uh, Naming variables really badly. And if you do any work in Spring Boot, the magical annotations can, it's like, holy cow, what's the annotation for this particular thing I'm trying to do? It's craziness. If you think about it, most of these look like code smells. And the bottom line is that code that's hard to read, it's also hard to maintain. Um, so you'll you're more likely to introduce bugs if you don't know if you're having trouble reading the code, and if the code is already kind of a mess, we tend to follow the pattern of the code that is already there. So we'll probably just, you know, add to the mess rather than cleaning it up. And that makes cleaning it up later that much harder. Um, we're not talking about refactoring right now. We'll get into that later. But right now we're going to focus on our ability to understand this code that we work with so that we can maintain it well. All right. So generally, why do we want to read code? You're going to want to learn. You want to learn how does this code work because I've either got to fix a bug that's in it or I need to add some new feature that somebody's asked for. A lot of times if you want to learn how to use a library, you've got to look through the example code to see how to properly use this library, how to make the function calls. And especially if you're going to conferences and that sort of thing, they'll have example code that's showing off this new technique that they're doing, or you're reading Uncle Bob's book and you want to learn how to write clean code, you'll read that. And then we always love code reviews. That's sort of everyone's favorite is reviewing someone else's code. We go back to I didn't write it. It doesn't make sense. So in Programmer's Brain, Felina Hermans talks about how our brains work. And she gives suggestions on how to use that knowledge so we can increase our ability to learn more effectively. And I'm kind of a brain information junkie, so I'm always wanting to figure out how to use this tool between our ears more effectively. And this book has just been a gold mine for me for all kinds of really cool insights and suggestions. So on the right side here, we have this map of how the brain works. I got it from Felina's book, and I find it really helpful. And we're going to be referring to it a lot, as well as her book. So the thing is, when we learn something, it we're inputting information into our brain. It passes through this filter of our experiences and assumptions and beliefs. And after that, it gets stored in our short-term memory. And that short-term memory is very small, between 5 and 9 things at a time. I don't know if you've ever heard of Miller's magic number, that we're able to remember 7 plus or minus 2 different things. So after that, it'll move to our working memory, where it gets associated with something in our long-term memory, and that's how we're able to remember things. Okay, so we're going to dig into this a little bit and see how this works specifically for developers. All right, so there's 3 different ways that code can be hard to read. First, it may have an unfamiliar syntax. And here, this is APL, and it's quite literally Greek. So it uses Greek symbols and stuff to do so. Have you ever used APL?
No, it's very interesting. I just read listened to the first chapter of the book, and in that they exactly talked about this.
Right.
APL and the next 2 examples.
Okay.
So,
and this is the first language I learned when I was in college, which is crazy. I'm glad I took basic in high school. I don't know how people made it through college learning APL.
You said nobody uses this currently, right?
It's used. It's actually it's a powerful language. It came on. We used an IBM mainframe at my school, and so yeah, it was. I had a couple of friends who actually got jobs in government, like aerospace companies and that sort of thing, using APL because uh, it's optimized for manipulating matrices, where matrices doing matrix multi-dimensional matrix calculations, and the symbolism is designed to make it easier to do that. And yeah, I when I was in college, I was really good at it, and now I'm not. It's been a few years. Uh, Another way we get confused is if we don't really understand the specific syntax. You may have a good idea of what it's trying to do, but you don't know exactly how it's going about it. I know that even after a decade, a lot of people are still confused by Java lambda expressions. So, so that can make code hard to read, or how Java was it the streams, how Java streams work, and how to hang things together that way. So if you understand how those work, then it makes the code very easy to read. But if you don't, then it can be very confusing. And finally, you can get confused if the code has a really sophisticated algorithm and it's hard to follow. Um, Say it has a high cognitive complexity. You can't hold all of these variables and functions in your head at the same time. So we call that lack of processing power. So yeah, lack of knowledge, lack of information, lack of processing power. Okay. So looking back at our map of the brain, we use this model as a means for how we might overcome the three types of confusion. So you can think of the long-term memory as like the hard disk on your computer. And the short-term memory would be your RAM, and the working memory would be your CPU. Okay? Actually, short-term memory might be more like your registers than your RAM because it's really small. And so Felina calls stepping through a program in your mind. She calls that tracing. Um, so how does our brain work when we trace through a program? First, we're going to read some couple of lines into short-term memory. And you consider that short-term memory lasts about 30 seconds on the outside. And then, remember, we got Miller's magic numbers, so we can remember 5 plus or minus 2 things. And actually, recent studies say that with the advent of social media and doom scrolling, that our short-term memory has gotten even smaller. And so it might be more like 4 plus or minus 2 things, which is distressing. Um, so So we have to find a way to make our short-term memory more effective. So let's have an exercise real quick, okay? I'm going to show you some characters, and I want you to see if you can remember them, okay? Ready? All right. So that's hard to remember, unless you're in Russia, and even then it's probably just nonsense. So, um, so why is that so hard to remember? Well, we've overloaded our short-term memory with information, and it can't really do anything with it. Okay. So we'll try something different. All right. Ready? All right. So now that was almost possible. In fact, if you tried to write those letters down, you'd probably be surprised that you likely remember more than you thought you would. But why is this easier? Well, we already have some association with the symbols that we saw in our long-term memory. And we recognize those symbols, and also the symbols, you notice, were grouped. There were 3 groups. So that's called chunking. We'll get to that later. So we'll try we'll try one more exercise. Ready? All right. Now that one was easy to remember. So why is that? Well, we can associate the letters with something in our long-term memory, but also the particular combinations of those letters are stored in our long-term memory. Goodness, excuse me a second. So yeah, we call that chunking. So when we chunk those groups of letters into combinations that are familiar, then we're able to process more in one in one uh, in one step, working through our short-term memory. And just for interest's sake, the when we when we read code, it goes through the filter, and it represents, whatever personal filter we have, your experiences, your beliefs, your health. You might be tired that day or something like that. Cultural assumptions, and then before it gets to the short-term memory, it passes through something called sensory memory. You can think of it as sort of an I/O bus. So when you see something really quickly, like we did, those first groups of letters, you can have a sort of mental picture of it, and that short-term memory is called iconic memory. And from here, you can make very quick associations with something in long-term memory. So that's why when you're just seeing the random letters, you actually might be able to remember more of those than you think you would, because if you try and write it down right away, that iconic memory still has it. It's sort of like a persistence of vision kind of thing when you see, lights moving at nighttime. So you're an experienced developer. What's the first thing you do when you're looking at unfamiliar code?
Slow down.
You slow down. So we're looking at this unfamiliar code. More than likely, you're going to glance at the shape of the code, and it'll give you some idea of the structure and the design. Okay. If you use IntelliJ, this little thing on the side, it's a plugin called Code Glance Pro, and I use it to help me dig through unfamiliar code. You can look over here and see, okay, this is likely a loop or an if statement because it's all indented, and this is probably a function call here with a long parameter string, and you know, you see this is what's highlighted over here in the screen. You can see here, these are case statements very quickly, and then there's the if statement inside there and if else. So just by seeing the shape of the code, that gives you an idea of the structure of the code. An if statement inside of a case statement, you can tell this is well-written code. Um, so yeah, CodeGlance Pro is a plugin for IntelliJ. If you use Eclipse or VS Code, they have something like this built in. It's just a configuration setting. So anyhow, um, so let's get back to our brain model here. We can increase the effectiveness of our short-term memory by chunking, and by that I mean we hook it onto something in our long-term memory in useful groups and collections. So what are some ways that we can chunk the code that we read so that we can understand it more quickly? I've already given you one simple tool. You can try and recognize the shape of the code. What are some other things?
Um, how it's composed,
Right. And what
like
do you mean by that?
variables, functions,
So the
unit
structure of
classes,
the
the
code.
structure
Right.
of the.
Mm-hmm. Okay. And then there's, of course, design
Reference.
patterns,
Yeah.
right? And design patterns are designed to be a way to attach a large set of information to a single word or idea. This is the publisher subscriber pattern, also known as an observer pattern. And if you know its implementation well enough, you'll be able to recognize it when you see it in code. And design patterns are a really useful way to communicate relatively complex ideas very quickly. So it's useful to know at least the fundamental design patterns. I used to race sailboats back in my young and crazy days, and having the captain of the boat, whatever you call him, the skipper, say, and trim the jib sheet was a much more succinct and useful phrase for me than say, okay, go to the front of the boat and on the small sail, pull the rope so that the small sail in the front is parallel to the sail and the mainsail in the back. Then cleat it and then come back here and sit by me so that we got to, no one's got time for that. If you're in the middle of a sailboat race, you need someone to trim the gypsy. Okay, you can say, okay, he sees that it's not optimally trimmed, so I need to run up there and trim it properly. Anyway, so you want to be able to communicate things using smaller words. This is why we develop jargon in whatever industry we work in. The financial industry, the medical industry, the energy industry all has certain jargon that they use to communicate concepts more quickly. We do that in software development as well. So, and documentation, looking at the documentation can be helpful. Now, studies show that developers who are less experienced will depend more on comments than people who have more experience. Why do you think that would be? Once bitten, twice shy. So we can have comments that explain why something does what it does. So like this, if the view mode is set to digital, we need to save the title. So we've got that's why we have this title variable here. Or we might have section comments. So this section of code does all of this. And generally, if we're going to have something like that, I would recommend you turn that into a module, a subroutine that you can call and give it a good name. Something like clear the text from the toolbar search field. That'll make your code a little easier to read. So comments like this or good method names are called beacons because they help the reader to find their way through code, similar to how a lighthouse beacon helps sailors to find their way on the sea. And there are simple beacons and compound beacons. Simple beacons will be like a single concept or a variable name, and compound beacons would be combinations of elements. So the compound beacon would be like a design pattern, whereas a simple beacon would be like a method name, that sort of thing. So why does this matter? Well, when you write your code, you want to leave helpful beacons, right? Okay, so with that in mind, let's see, how do we use what we've learned already to run into the different kinds of confusion we have? All right, so our first problem is we don't know the language. How do we overcome that? Well, we learn about it, we research, we study, we learn the syntax of the language, and we add that syntax to our long-term memory so we can be able to start understanding the code next time we see something familiar. I will say that I've spoken to a number of speakers at the conferences I go to, and a lot of them use presentation-driven learning, where they've decided they want to learn some new technology. And if I want to learn some new technology, but I don't have a reason to, it makes it really hard and I probably just will never get around to it. But if I'm going to be doing a presentation on this in a couple of months, then I'm going to dive into it heavily for a month or so, make sure I understand it and learn it as quickly as possible. And then I'll put together a, 45-minute presentation on it and leaving 5 minutes for for questions and answers. So having a reason to learn something will help us to learn it more quickly. So learning the syntax, I can teach you the syntax of APL. It's you read right to left, one character at a time to uh, to parse APL. So and we can walk through. Okay, so this is an array, and then I forget what the semicolon means. Oh, semicolon is what they use for an array index. So this is a two-dimensional array. And so this is only going to look at the second dimension, and this is the ceiling, so that means it's going to find the maximum, and then this is a a append. It's whatever. I'm not going to explain APL to you. You're not going to understand it, and you're not going to care, right? So this is where we go to the comments. This evaluates a determinant. There you go. All right. So the next kind of confusion we have is I'm not familiar with the syntax. So I've got this print formatted function here, and so this format. What is a format? String function? I don't know. So how do I read this more quickly? Well, I need to become more familiar with the code structures, and I need to practice them and learn them and make sure that I understand. Okay, so this is a lambda that is operating on here, and this s plus. So this s must be a string. So flame s plus. So all right, so I don't understand how that works. So I'm going to have to learn how the lambda function works. And so this is what my string function is. Oh, here we are. So it's going to run this lambda. I see. So being more familiar with how lambdas work and frankly how interfaces work, I can read this code more quickly and understand what it's trying to do. And finally, we've got code that's just too complex to read. I've got this crazy algorithm, and it's hard to follow. Like I said, it's a high cognitive complexity. How do I read this kind of code more quickly? Well, this is where you're going to need an external brain extension. And I usually call this a printout. So I'll print it out and I'll step through it and I'll keep track of variables and values and calculations and function calls and that sort of thing. These days, debuggers are a lot more advanced, so you might use a debugger to make it easier to do that. We'll talk about that later, about how to get better at doing that sort of thing. Okay, so we're going to do a quick exercise, and this is to practice noticing beacons in code and understanding a small snippet of code that we're unfamiliar with. I'm going to give you a couple of minutes to look at a piece of code and make note of the things that you notice as beacons, okay? We want to get better at noticing beacons so we can more quickly understand unfamiliar code. All right, so let's take a look at this. So what are some of the beacons that you notice as you're looking at it?
The comments, the method name,
Right,
and then the parameters.
Huh?
then the eval, the structure,
Right? See that it's basically checking
and
this or that or the other.
variable names.
Hmm. Builder is a material dialog builder. Hmm.
Design pattern.
Yep. And then you have the name of the method is show removal. So this is going to, depending on, what kind of things are going to be a comment or a submission, anything else, we're going to ignore it, right? Um, of the curly braces, the way they've got them structured, they can help set off sections of code. If you're doing like C# development, then they don't put the curly brace at the end of the line. Their standard is to have all the curly braces uh, at the same level. And frankly, that studies show that that makes code easier to read. But if we're going to follow the programming standard of the language, then this actually makes Java easier to read. If you look at constants, these are constants. Now they don't follow the Java convention, um, but uh, these point to internationalization constants. If you go and look at the code that came from, these point to internationalization constants for supporting multiple languages. So I will say that I don't like the name thing for a variable, but the other names seem to be well chosen. Context, callback, those are helpful. So all of these beacons help to make the code a little bit easier to navigate. And if you make it a point to leave beacons in your code, then it will make it easier for future developers to understand it later. And that future developer may well be yourself. Um, and as you gain experience reading code, you're going to notice things that are beacon because your eye is just naturally drawn to beacons, right? Okay, so our first two ways of getting confused are remedied by learning stuff and remembering it. How do we make remembering stuff easier? Do we really need to remember stuff? What's wrong with Google? Isn't that supposed to keep us from having to remember everything? Okay, so there are a number of really good reasons to just have that information in your head ready to use. First, the more you already know, the faster it is to learn. What do you think that would be? When I'm learning something, what I have to do is I have to hook it into something that is in my long-term memory. And the quicker I can do that, the better I'll be, the quicker I will be able to understand what it is I'm looking at. So if I already understand how lambdas work and how Java streams work, I will be able to quickly understand code that's written in Java without having to go back and remember, okay, how does this work? Or, take this code and submit it to ChatGPT and say, how does this code work? I can just read it and understand it quickly. Also, if I stop to look something up, I break my flow. Uh, there's a guy named Csikszentmihalyi, whatever. I read his book some years ago, and he wrote a whole book on flow. I don't know. Are you familiar with the term flow?
Yeah,
Yeah. So you get into this state of just working, and
I
everything
get
just
kind of
falls into place. Right. So we want to get into that state of flow and spend as much of that our time in that state of flow because frankly it's fun. And we get more done more effectively when we're in that state of flow. And finally, if you get distracted, having to look something up, it takes on average about 15 minutes to get back to where you were, to cram all the context of what you were doing back up into your brain. And if you're anything like me and you have to look something up on the internet, you go to Stack Overflow and they give you the answer. You'll notice on the right side, they've got other people who've asked similar questions. And then they want to introduce you to other Stack Overflow libraries, and you can go look up stuff on Lord of the Rings or movies or learning new languages or whatever else people are wanting to learn about. And half the time I'll just say, "Oh, that's an interesting question. Why didn't they use eagles in Lord of the Rings to just fly them in there? It's, oh gosh, oh yeah, that's a good question. Oh, why didn't what about that? And then I spent 45 minutes digging through Lord of the Rings when all I really wanted to know is how's a freaking lambda work. So anyway, um, there is a concept uh, called the memory rate of decay. The way our brains remember things is usually through repetition. Um, you know, I guess there's a couple of different ways that we remember things. We'll remember things when there is some traumatic event. We'll usually remember what's going on then. A lot of people, most people can remember where they were when the planes flew into the towers in September 11th. Um, um, but we generally don't want to have that kind of trauma in the work that we're doing. That would be bad. Um, Although I will say that some of the most embarrassing problems I've run into, I vividly remember them, and I'm very careful to not make the same mistakes again. Um, but there is when you learn something, we go into there's a decay in how we remember it, and it generally follows a more or less logarithmic type of decay. After a day, we'll forget about 40% of it. After another day, we'll forget another 20% of it. After another 6 days, we'll forget even more of it. But there is there's an exercise you can do to try and remember stuff more easily. And so after one day, if you go and you review what you learned, then you'll remember it longer. And then if you go after 3 days and you review, you remember that longer, and you'll see that the rate of decay slows down. So you'll remember more, and you'll remember it longer if you go back and you review it at specific time intervals. There is this website, it's ncase.me/remember. This gal is named Nikki Case, and she has this really cool website that goes into great detail about, you can create you a shoebox that does this, or there are various apps that you can use that help you with it. This is what the homepage looks like. So if you go there, this is what it looks like. And yeah, she does a really cool job of creating a website that makes the stuff that she shows really easy to remember. So it's really nice. So there are these apps. Anki, Cerigo, and Quizlet are these flashcard apps that help people with this specific exercise. So if you're wanting to learn a new language and you want to learn the syntax, you can create cards for yourself and then drill yourself on the what's called flashcards. This is how I learned my times tables when I was young. My father sat with me with flashcards, and they are actually helpful. And since a lot of developers are trying to learn a lot of things, chances are there is a library out there that already, or a card deck out there that has the things that you're wanting to learn. Although it's generally more helpful for you to make your own cards because, again, we remember things that we want to, we remember things that we have a reason to. And so if we're more invested in learning and so that we even create our own cards, then we will have a better chance of remembering it long term. Um, so one other thing is that you remember better by practicing remembering. So it's important for you to read the prompt on the flashcard and then try to remember what the answer was before you flip it over and see what the answer was. So that remembering is sort of a muscle you have to exercise with, just like your memory. There's basically two different ways that we can strengthen our memories, right? You got your storage strength and that's that the things that are in our memory tend to stay there, and our retrieval strength, and that's our ability to recall what we've already stored in our long-term memory. So you've probably been in a situation when you needed to remember, like your wife's phone number or your social security number. It's like, I know this, I know this, I just can't remember it right now. and, and it's not a problem. You know that it's in your memory. It's just you can't recall it. So you need to practice. You're developing your retrieval strength, and you develop your retrieval strength by practicing it, by instead of just instantly flipping that card, you try to remember what it was first. Okay. So um yeah, before you go to Google, try to remember what it is you were supposed to do. It's kind of funny. I store things at home in places where I know that I can get to them quickly. I store for quick retrieval, and my wife stores because she doesn't want to see it. So she'll, go to the counter and just slide everything into a drawer, and then she doesn't care if she ever sees it again. She just doesn't want to see it now. And of course, then she can't find it, and she calls me. And since I'm the one who, remembers where things are stored, I can usually find it for her quickly because I'm skilled at retrieving things. So we've gone for about an hour, and we're about halfway through here. What I'd like to do is stop here if we can, because this I've already gone over a lot of information. I would encourage you to go to this website and read through it, and learn about the importance of memory, and then get one of these tools. She mentions them in her website, um, and I will put that. I'll go ahead and record this. I'll put that link to that in the notes for the on the website, and yeah, we'll just leave it at that for now. Do you have any questions?
Yeah, one question came to mind. So with the Gen AI,
Right.
um, so retrieval became much easier, right?
Mhm.
And so one consequence of that that I fear about is the more we use Gen AI and rely on Gen AI, the dumber we will become eventually because we don't think, we don't remember, we don't practice remembering.
Right.
So what's your thought on that?
I think that's an excellent observation. Um, and there are actually studies that show that people who rely more on AI for what they're doing are losing their ability for thinking clearly, for writing. If you lean on Gen AI to go and create documents that you need to write, they become less skilled at writing. Um, and it's just like I don't write as well with my handwriting because I type almost everything. And so I've had to start practicing that because even I got to write checks now and then. If I can't make it legible, that's a problem. So yeah,
Hmm.
this is something that as you as you start working more with AI, you will have to, just like keeping any other skill sharp, you're going to have to practice this sort of thing. Again, the reading code, you could just submit it to ChatGPT and say, what does this code do? We'll talk about that some more next time. But that's, you know you're not going to always have access to that, and it's not always going to give you the right answer. So you still have to know how to read code at least well enough to know whether or not the AI is giving you the right answer. Um, so yeah, you'll need to practice reading and writing and doing a lot of this yourself, at least until AI becomes so good at it that that it can take care of it all for you. And I think we're still a number of years away from that being a problem.
So for programmers who use AI, do you have like guidelines? Like when should we not rely on AI? When should we use
Well,
AI?
well, so I guess I haven't put together my own specific guidelines. For myself, I can tell you what I do. Um, I first will try to read code that I'm unfamiliar with and don't understand. And if I struggle too much with it, I will submit it to ChatGPT or our company uses Copilot and say, okay, what does this code do? And use smaller snippets of code. I'm not going to give it a 5,000 line code base and say, what does this do? Because again, you have to think of the AI like a very persistent intern. So you have to follow up on the work that they do. And if you give an intern 5,000 lines of code to read, they're not going to give you as high quality an answer as if you gave them, you know, 20 to 50 lines of code to read. Same thing with ChatGPT and Copilot. Give it a small enough chunk that it can make sense, and so that you can go and verify that the answer it gave you was reasonable. Um, in generating code, um, regardless, generating or reading code, don't depend on a single AI. I There's a presentation I do on where I talk about how I was going to incorporate it next week, or talk about how different AIs have different abilities, and um, and so I would use multiple AIs to sort of check against each other, sort of like getting a second opinion when you go to the doctor, right? So get a second opinion when you go to the AI programmer to make sure that you agree with what it says. And of course, you have to be skilled enough to know whether your agreement or disagreement is well founded. So you still have to develop your own skill set. Does that help?
Yeah, yeah, that helps.
Okay. Well, then, so what I'd like you to do, like I said, is dig through this website, and it should take about 20 minutes to work through, not a big deal. And start thinking of some things that you might want to remember, and either set up a box. She teaches you how to set up a shoebox to do this, or buy an app, and not buy these are all free apps. Get the app to help you with that sort of thing. Um, and What I'd like to do, would you find it helpful to have? I'd mentioned this last week, having office hours where we have a like an hour where we just work together on something that it could be your work, or we'll just sit here and be together. Would you want to do that? And if so, what would be a good time?
Yeah, I think office hour would help. Um, um, I just need to figure out what I need to work on.
Okay.
Whether that's the Kubernetes certificate I'm preparing, or some reading comprehension, or some on some open source project, or something.
Okay, good.
Um, but do you have something to recommend?
Well, I mean, you've got specific things that you want to do,
Hmm.
and um, basically, I'm there to help you to get it done. And I can help you actively, or I can help you passively. That's what the office hours are for. Sometimes it's helpful to just have somebody sit there and say, okay, I have set aside this 1 hour to focus on learning this thing.
Hmm.
And um, and having somebody sit there with me gives me more incentive to go ahead and focus on it and not get distracted by something else that might come up. So I've made
Yeah.
an appointment. So
Hmm.
that's what I'm offering. I'm helping to sort of build the scaffolding of making sure that the skills you develop are going to carry over into the rest of your life.
Yes. Yeah. Okay.
And this is one of the skills to develop. It's called body doubling, and
Hmm.
uh, and I'm offering that for you.
Okay.
So
Yep.
you don't have to decide right now. Give it some thought. Determine when would be a good time. Drop me a line, and we will set up a time to work on this together.
Sure. Yeah, I'll let you know when.
Okay.
What would be your availability at
Um,
best?
well, I will tell you what. I will put a link to my calendar,
Okay.
um, and then we can just set aside a time to get together.
Sure.
Do
Yep.
that. Okay.
That works. Yep.
All righty then. Yeah, I'll put that in the notes, so that you know folks who weren't able to make the meeting, they can set up a time as well.
Sure.
All righty then.
Yep. Thanks, Scott.
Sure. All right. Well, you have a great week, and we will talk to you next time.
Yep. See you next time.
Have a great 4th of July holiday.
Yes, I forgot it's a long weekend. Yeah. Happy
Absolutely.
4th of July. Yeah.
All right. Bye.
Bye.